Right, so what's the example? It's example 22 on page 313. Okay. Yeah, diagram shows part of a curve. Yeah, well, it is part of a curve. Only the part that you need. Region R, which is that, is bounded by the curve, the x-axis, the lines x equals 0 and x equals 4, as shown in the diagram. Use integration to find the area of R. Simple as that. Okay. A legitimate question might be, what if you've not got the diagram? What if it just says find the area bounded between that, the lines x equals 0, x equals 4 and the x-axis? Would you need to draw the curve? Probably not, no. The only awkward cases are where it crosses the axes. Let me just give an example on the exercise, maybe just turn to it, okay? Page 315, see that example there? Yeah, see that right? So the example is when you need to integrate between there and part of it goes below the axis. Okay, that's the only difficulty you might have. Okay, but you can quickly check if you need to. Okay, the y-intercept is easily done, of course. So you just put x equals 0 into that, you get 9 over 2, which is that 9 over 2. And because of this reciprocal function, you're never going to have y equals 0, are you? Okay, you're not going to have 9 divided by number equals 0. So it's never going to cross the x-axis. Okay, so what that means is it's not going to suddenly have a positive area and a negative area. So you're probably free to actually go ahead and integrate it even though you don't know what the curve looks like. That's the same with most questions, okay? Why does the curve look like this? Briefly, well, as x gets larger, we say as x tends towards infinity, the denominator is going to get larger as well. Even though you're square rooting it, if x gets larger, the denominator gets larger, won't it? And so 9 divided by an increased large value, y gets smaller. While it just gets more and smaller and smaller, 10 towards 0. Okay. Yeah, or does it tend towards 0? Yeah, it does tend towards 0. Okay, so let's just go and integrate it. So this is nothing new. Okay, you've done this before. This would have been in one of the inspection series of questions. All right. Okay, but I'll just go through it with you. It's kind of like a recap because you're probably thinking, oh, please don't do it quickly. I need a recap. Go as slowly as possible. Yes, well, not as slowly as possible, but I'll go step by step. All right. So the first thing you want to do is just to rewrite it. Okay. So integral between 0 and 4, and write it like this: 4 plus 3x to the negative half. Okay. Because it's not a natural logarithm because it's square rooted, of course, and yeah, it's not a substitution question because it's quite an easy one. Okay, so not a by parts question either, is it? So you got that. Okay, check what you get when you differentiate the brackets. You get 3. Okay, there's no x term there, so we're fine in terms of the numerator. So what it means is a simple, normal approach to integration. Okay, you increase the power by 1. Okay, so power by half. So your answer should look something like 4 plus 3x to the power of 1/2. Yeah, that's what your answer should look like. Okay. Now at this stage you might be thinking, yeah, but I can't quite remember what to do next. Okay. Well, let's just pretend that's our answer. Yeah. So y equals 4 plus 3x to the half, and I'll just ask you to differentiate it. Yeah. Maybe just pause the video, differentiate it. Okay. Or otherwise just go with what I'm doing. So you've got half times 4 plus 3x to the negative half, of course. Yeah. And then multiply by 3, so you get 3 over 2. 4 plus 3x to negative half. Okay. And you can see that this is very nearly the same as that. Okay. You just got to decide what to do to make it different. Okay. Or what you do is just think, well, there's definitely a 9 there, isn't there? So even if you just took the 9 outside the integral bracket like this, yeah, you can do that. If you want, you can do it. You're going to have a 9 at the front, aren't you? Okay. And then what else have we got to do? Well, we know that when we integrate, we've got to divide by that power. Okay, so we'll divide by 1/2, so that's going to be times by 2. So that's 18, isn't it? Yeah, 18. And we know that when we differentiate what's in the brackets, you've got to divide by the, what you get, you divide by 3. So 18 divided by 3, that's going to give you 6. Okay, so your answer in there should be 6. Okay, and what you'll do is you just check by differentiating. Okay, just put in a 6 in front of that, which means I've asked to put 6 in front of that. Put 6 in front of that. 6 times 3 over 2 is 9. Okay, and that's our answer. Okay. Notice I've not put the plus C because it's an area question and there's limits. So, you know, no plus C. Okay. There's no limits. Bond has no limits. Hey. Yeah, that was one of the advertising slogans in the early days, I suppose, 70s, 80s. Okay, Bond has no limits. Okay. They're not doing that anymore. I don't know what the slogan is. Okay, it's always been licensed to kill, of course. Well, I've got a license to teach maths. I do. I've got a teaching qualification. It's kind of like my license. Okay, it's not as cool as a license to kill, but it's a license to teach maths. Okay, let's just put the limits in. 0, 4. Okay, I've also got a driver's license as well. And no way is that as interesting as a license to kill. I'm not sure I want a license to kill, to be honest. It's kind of, yeah, a lot of responsibility comes with that. I'm being serious for a moment. Let's just put in the 4, shall we? So you've got 4 plus 3x, so that's 12 plus 4, 16. Yeah, square root of 16 is 4. Yeah, 4 times 6, 24. If only this was 24, Jack Bauer. Yeah, that would have been so cool, but it's not, is it? And then put in 0, so you get 4 to the power of half, so square root of 4 is 2, times by 6 is 12. Yeah, 24 subtract 12 gives you 12. That's it. Okay, done. Yeah, well, it's not really much you can do that's different, to be honest, okay? A question I'm sometimes asked is, do you bother with units? No. No, one of the few times you don't bother with units. Radians don't bother with units, do you? Like the angle is, pi over 2, 3 pi over 2, 2.1. You don't put radians, do you? Okay. With this kind of similar thing, when you integrate it to find an area, if it pleases you, then you put square units. Like that. Okay, if it pleases you. Okay, otherwise it's fine. Okay. Right, that's it. That's the first example. The next example is coming right up. Okay, hope you enjoyed it.